Alright, in this video I'm going to be solving this question here. This is a two-dimensional projectile motion problem. A football is kicked with an initial velocity of 25 meters per second at an angle of 45 degrees with the horizontal. So, if I'm going to draw a picture, which everyone should to begin, here's our football. It is being kicked and it makes a parabolic arc in the air, and it lands on the ground at the same vertical height of where it started. It is launched at an angle of 45 degrees with an initial velocity of 25 meters per second. Determine the time of flight, the horizontal displacement, and the peak height of the football. So, in addition to just these three things, we will have to solve an additional three other variables. So, in order to organize all of our answers, I'm going to draw a box that will have all of our answers. One of the first things we actually have to solve is the initial vertical and horizontal velocities. We will have to also solve the total time total that the ball is in the air. We will have to find the time that the object reaches its peak. We will also have to find its total distance traveled in the x direction and the maximum height distance at the peak. So these 6 things we'll eventually solve, and I'll put everything back in the box as we go. One of the first things we have to do is find the initial velocities of the original velocity vector. We'll have to split them into its components. So I'm going to actually take this initial position, initial condition circle, and I'm going to expand it in the middle here. So I'm going to take a vector that is 25 meters per second, and it will be decomposed into a horizontal velocity and a vertical velocity. This is at an angle of 45 degrees. One other way I'm going to organize all of my answers is to have a side dedicated to all of my vertical information and one dedicated to my horizontal information. To start with our vertical information, I'm going to find our velocity initially in the y direction, which is vertical. The equation for that is to take the original velocity of 25 meters, multiply it by, since the vertical is opposite, that will be the sine of theta. I'll plug everything in. That equals 25 times sine 45. That should give us a 17.7 meters per second. And I'll just go ahead and put that in here for initial velocity in the y direction. I'll also find the horizontal information. The horizontal velocity initially in the x direction is the initial velocity times the cosine of the angle. Plugging that all in, we get 25 times cosine of 45. And that also gives us 17.7 meters per second. This makes sense because the angle is 45 degrees. If it's a 45-degree angle, that's halfway between 90. So the horizontal and the vertical components should be equal. One other thing that would be useful to find, but we actually don't have it in our box, is actually if we know the initial velocity, what about our final velocity in the y direction. Our final velocity in the y direction is actually the negative of the initial velocity in the y direction. One, we know that this is a fact. At the same height, velocities are equal in magnitude. In addition, we can prove this, so I'm going to go ahead and prove this by using one of our equations. One of our equations states that our final velocity squared is equal to our initial velocity squared plus 2 times the acceleration times the change in distance, which is y minus y0. If we're talking about the point where the football is kicked off and where it lands, that change in height is 0, is the final position or final height, and the initial position is also 0. 0 minus 0 equals 0. If you multiply it by anything, this all cancels out to be 0. So if that's the case, we have v squared is equal to v0 squared, which is, if you take the square root of both sides, you'll know that 1, the initial velocity is going up, so that's positive, and the final velocity is going down, so that'll be negative. So that should be enough of a proof for us. Alright. One other thing that we can also find out is, and one of the things we should find out next, is our total time. We have to go to our equations that have time, and one of the best ways and one of the best equations to find time is actually the simplest equation. That is, the final velocity is equal to the initial velocity in the y direction plus our acceleration times time. We know that, and actually I'll label this finding time total. We know that our final velocity is negative 17.7. Our initial velocity is 17.7. This negative 17.7 came from right here, where our final velocity is the negative of the initial velocity, plus our acceleration is negative 9.81 times t. In order to solve for t, we isolate it, so we take 17.7 to the left side. These 17.7's cancel out, and you're given negative 35.4, and that should equal negative 9.81 times t. In order to get t by itself, we'll divide both sides by negative 9.81. Negative 9.81. Negative 9.81's cancel out, and you will get a t that should equal 3.61 seconds. I won't put that back. T total is 3.61 seconds. Alright. We're going to go ahead and skip our time at the peak for a quick second and actually go to the distance, or how far the football is kicked, dx. So I'll actually label this next section finding dx. In order to find dx, we use our equation. Our horizontal position is equal to our initial velocity in the x direction times our time. Our initial velocity in our x direction is what we just saw. v0x is equal to 17.7 meters meters per second. And then another thing we know is that our time, this time is the total time it's in the air. One of the same things on the right side as for the left side is the time. The time for a football to go in the air, to come back to where it is the same time going horizontally as it is going vertically and then back down. So our time here is still going to be 3.61 seconds. So to plug everything in, x is equal to 17.7 times 3.61, and you get a horizontal distance of 63.8 meters. So we'll put that there. The distance traveled in the x direction is 63.8 meters. Alright, all that's left is to find our information about the peak or our maximum height. And if we go here, our maximum height, one of the things of being on level ground and kicking something up and back down is that level height comes halfway in between the total distance. So if we were to find our, and I'll label this peak time, time at the peak, we're actually going to use our horizontal information. Our time at the peak should be 1/2 the total time, which gives us 3.61 seconds is our total time, divided by 2 is 1 point, we're just going to estimate it at 1.8 seconds. 1.8 seconds goes there. And then we want to find, last but not least, our distance, or our maximum height, distance in the y direction of the peak. I'll use the bottom half to do that. Distance of the y of our peak. Another word for that is maximum height. And in order to do that, we know that one of the best equations we have is y is equal to the initial position plus the initial velocity in the y direction times time plus 1/2 our acceleration times time squared. Since our football starts at the ground, or it is also starting where it starts, our initial vertical position is going to be 0 meters. We know our initial vertical velocity to be 0 in the y, and that is 17.7 meters per second. The time at the peak is not 3.61, but actually 1.8 seconds, because we're actually looking for the vertical position at the maximum height, or at the peak. And our acceleration is negative 9.81 meters per second squared. If we plug everything in, we get y is equal to 0 plus 17.7 times 1.8 plus 1/2 times negative 9.81 times 1.8 squared. And if you plug that into your calculator, you should get a vertical height of about 16 meters. So we'll go back to the beginning. Our peak height is 16